Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Dutch Flatmates 8 Lines by Flinty, and here are the rules. We have normal Sudoku rules apply, which is place the digits 1 through 9 so that they do not repeat in any row, column, or 3 by 3 box. We have Dutch flatmates, where every 5 in the grid must have a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need both. So every 5 in this puzzle must have a 1 above it or a 9 below it. And it could satisfy both of those rules, but it doesn't have to. And finally, we have 8 lines, where each line consists of one or more contiguous groups of cells, each of which sums to 8. And these groups of cells cannot overlap. Interesting. Digits may repeat on lines and even within sums. So as an example, you could have something like, say, 3, 2, 3, 1, 7. And this would be valid as an 8 line because it can be divided into sections or contiguous groups of cells, each of which sums to 8. And the groups do not overlap. So we have 3, 2, and 3 adding up to 8, and we have 7 and 1 adding up to 8. And obviously there's no overlap there. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, well, one thing, 9 can never be on this line. So, in column 8, we have 8 cells, which all have which all are on an 8 line. So that means the last digit in that column, which is not on the 8 line, is a 9. We also have, these are 3... Well, that's not true. Huh. Interesting. I was thinking that there's no way that you cannot have... This has to be 3 unique digits adding up to 8. But you could have 2 digits adding up to 8 and an 8 itself there. Interesting. This has to be 2 unique digits adding up to 8. It cannot be 2 sets, right? Because that would require an 8 and an 8 on both sides. So this is either 1726 or 35. And that's the same for any, well, that's the only two length line. That's an 8 line. Interesting. So the 5 in column 8 has to have a 1 above it or a 9 below it. That doesn't help us right now. Row 2, every digit is on an 8 line except for 2. So that means the 9 has to be in one of those 2 remaining cells. What else can we do? Oh. 4 has to be somewhere in column 8 on an 8 line. The only way 4 is on an 8 line is it adds up with 2 other digits to add up to 8. Or I guess you could have 4 with 4. So 4 can either be with 4. Technically, it could be. So where can 4 be on in column 8? Cannot. It could be here. 4, 1, and 3 is possible. You could technically, you can't have 4 and 4 here, so that's not possible, but it could be 4 with 1 and 3 also here. Or you could have 4 and 4 here, or 4 with 1 and 3 here. That's interesting. Uh, um... One thing we know is, okay, this digit has to be either a set of 3 digits adding up to 8. Well, it could be any of the 2 sets too, though. So it's 1 through 7. It just can't be 8 by itself. Huh. Okay. Where is 9 in box 7? Can't be here because of 9 in the row. Can't be on the 8 line, so 9 has to be here, which eliminates 9 in the rest of the column. So that's not 9, so 9 in row 2 has to be there. Interesting. Okay. 9 in column 7 then has to be one of those two because 9 can't be here or here because of 9 of the boxes. No 9 here, but 9 could be any of those. We know this can't be 8 because that would break these into separate sections, which would have to add up to 8, but that's a singleton digit. So no 8 there, no 8 here. But this could be 8. You could have 8 and 8 there. That would be perfectly fine. This can't be 8 for the same reasoning. Huh. Hmm. Um... I'm not sure how else to approach this. So 9 is obviously kind of limiting factor, but not greatly limiting. 8 and 4 on the lines is interesting. but it's not. Okay, this can't be 8 because that would force this to be an. Oh, you could have 8 and 8 there. That's fine. Right. This can't be 8. That would force an 8 here, and therefore would be repeat in the column. Same with this. This can't be 8 here. That would force an 8 in the same box. No 8 here. You could have an 8 here. You could have an 8 here. No 8 here. That's not too helpful. Maybe, yeah. Just highlight where the 8s can't be. 8 can't be either of these either. Hmm. Then you have the Dutch flatmates, which is also restrictive. This can't be 8 because again that would force an 8 here. Um, Oh, that is interesting. What happens if we have a 4 here? If we have 4 here, that would force us to be a 1-3-4-1-3 triplet adding up to 8. Because 4 with a doubleton doesn't add up to 8, and 4 by itself doesn't add up to 8. So 4 has to be, because a 4 with a doubleton would have to have 4 and 4, and that can't be in the same box. So if we have 4 here, this would be 1, 3, and 4 remaining on this line. So if we have 4 here, this would have to be 1, 3, or 4. This would be 1, 3. That would eliminate 1 and 3, 1, 3, and 4 in the rest of the box. So no 1, 7 here, no 3, 5 here. It's 2 and 6. Well, where can the 5 be in this box in that case? 5 would have to be here, here, or here. But 5 here doesn't have a 1 above it or a 9 below it. 5 here does not have a 1 above it or a 9 below it. And 5 here does not have a 1 above it or a 9 below it because we have a 9 in the column. So this cannot have a 4 here. That's actually pretty good to know. So this, okay, so we have that. So this cannot be a 4 here or a 4 here. So this could be 1, 2, 3, 5, 6, 7, 8. So 4 either has to be one of these two or one of these three. Well, what happens if we have 4b here? That means, again, you can't have two unique digits adding up to 8 because with the 4, which would be because it would have to be 4 and 4, and you can't have one single digit adding up to 8 with a 4. So if there's a 4 here, this must again be a 1, 3, 4 triplet. That eliminates 1, 3, and 4 in the rest of the column. So no 1, 3 here, which means no 5 there, 5, 7 there, no 1, 3 there. Five cannot be any of these digits because 5 has to have a 1 above it or 1 or a 9 below it. So since this can't be 5, that can't be 3. this is either 1, 7 here or it's 2, 6 here. That's interesting. This could be an 8 by itself. Neither of these can be 7, because 7 and any other digit here is not going to add up to 8. And 7 by itself can't add up to 8. So we either have an 8 here or this is a 2, 6 pair. If this is 8 here, this would be 2 and 6, which would have to be with the other 2, 6. So this would have to be 1 and 7 there. So the remaining digits here would have to have a 5 in one of those, and then 2 or 6 or 8. Well, 5 couldn't be here, because 5... as a doubleton, it would have to be 5 and 3. None of these, I guess it could be 5, 2, and 1. No, this can't be 1. 1 eliminates 1 here. So no 1 here. So you can't have 2, 5, and 1 that way. You can't have 2, 5, and 1 that way because of the 1, 3, 4 triplet here. This would either be 2, 6 as a pair, which would force this to be 8 and 5. I guess you could have 8 in here, 8 here, and 5 there. That would be 3. No, and then you could have an 8 there. That is possible. So that's a possibility. What was that? 8 and 8, 5 and 3, and then 8 there. That does work. What about if 5's here? If 5 is here, that's 1. Well, we're assuming this is 2, 6 as a pair there. So we have 5 there. That would force us to be 1. So no 1 there. It's 3, 4 as a pair. And we were saying this is 8. So 5 would have to be with 3 here. And that does not work. What happens if we have 5 here and then this is an 8? Then this has to be 2 or 6. We can't have 5, 2, 1 there because this can't be 1 because of the 1, 3, 4 triplet. Can we have... can we have 5 and 6 at... No. That's 11 already. Can't have 5, 3 here because of the 1, 3, 4 triplet here. Can't be F5, 2, 1, so that doesn't work without... Actually, it doesn't even work, period. So this can never be 5 in that instance. So can we have 5 here with a 2 or 6? Yes, because then this would be 2 or 6 also. And the 5 would be above a 9. So that's fine. So that does work in that situation. What happens if we have 4 here? Well, you could have 4 here and then 4 here. That is possible. Not the most restrictive here. I don't have any intuitions really about the 8s. The 8 lines. I'm not very good with Dutch flatmates in general. I don't tend to enjoy these, but this one I was curious about because of the 8 lines. But this might actually have to require a decent amount of the Dutch flatmates intuitions, which I'm again not good at. Um, I don't really enjoy them either that much, but they are an interesting like rule set, a restrictive rule set, which has a lot of applications. It's just something that doesn't really tickle my fancy, really. Um, hmm. I was in this case, I was more interested in the 8 lines and how those interacted. It's definitely very different. This is, I think, an offshoot of the 10 lines, where you have to have sets of digits adding up to 10. But the interesting part is you could have a singular digit here adding up to 8, which is actually throwing things for a wrench for me. Um, well, 8 has to be somewhere along this line. So you could have eight here, 8 here, 8 here, 8 here, or 8 here. Hmm. 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 Um. Yeah, unfortunately, this isn't as restrictive as I was hoping it would be. Um. Yeah, I think I'm just gonna have to go through examples and just try things out for each digit because I don't really see a restrict. I mean, part of it is probably I'm not very good with Dutch flatmates, so I'm not really. Um. Oh, 5 cannot. Where can 5 be in this box? It cannot be here. So 5 can't be here. Can't be any of it can't be any of these two. It could be here. Oh, this cannot be 512 adding up to 8 here. If this is 512 as a triplet, that would eliminate 1, 7, 2, 6, and 3, 5 in that box for possibilities of adding up to 8. So 5 can't be here as 512. It could be with 3 and 5. But then the problem is this 5 doesn't have a 1 above it or a 9 below it. So this can't be 5. You could have 5 and 3 there, and that would force this to be 8. So that is possible. Can you have 5 here? Yes, you could have 1 above it and a 7 there. So that's possible. You could still have 5 here and then 3 and 1 above it. This would be 3, and you'd have 2, 6, and 7, 8 there as a possibility. Can you have 4 here? If you have 4, 1, 3, um, that would again force this to be 2, 6. 5 again cannot be here. It doesn't have a 9 below it or a 1 above it. Can't be here because no 9 below it or no 1 above it. So 4 can't be here either. So this could be a 5 here. 5 and 3 with a 9 below it. 1, 2, no 3. Because 3 has to be with 5 as a pair or 1, 3, 4 as a triplet. And this can't be 1, 3, 4. Or 6, 7, or 8 here. Okay. 4 could be here. You could have 4, 1, 3, 1, 3. So, but 4 has to be one of these 3 cells. But that doesn't really help. That's pretty broad. And there's no real restrictions on it. Um, 5 cannot be any of these two. 5 can be here. 5 can be either of these. 5 could be here with 1 above it. So this is not going to be 3 digits adding up to 8. So we're guaranteed an 8 has to be one of these 2 digits. Right? We tried 1, 2, 5. Did we? Oh, yeah. We tried 1, 2, 5, and that eliminates all possibilities for this pair here. 1, 3, 4 doesn't work because that would necessarily force us to be 2, 6, and 5 would have to be one of these 3 cells, but 5 can't be in any of these positions. Therefore, we are guaranteed this is a pair of 2 digits and an 8. Oh, that's interesting. So this can't be 8 here. So we can't have 8 in any of these spots. 8 has to be one of these 2, which eliminates 8 in the rest of this column. Interesting. So 8 can't be here either, because the only way this is 8 is if this is 8 also. So 8 can be here, here, or here. Huh. Interesting. We have to have pairs of digits now. This can't be 5, because if it's 5, it doesn't have a 1 above it, and it doesn't have a 9 below it. So this is 1, 2, 3, 4, 6, 7. This could be a 5 if this is 1 and 7. Uh, hmm. Okay. Um. Hmm. Phew. I don't know. I don't know if I consider right now. It just doesn't seem. It doesn't seem very obvious to me that this is easy. It seems more like a challenging puzzle to me. But maybe I'm just. I don't know. These two must at least add up to 8. You could have 3 of these adding up to 8. I mean, you could even have 3, 2, 3, like I was talking about before. Mm-hmm. Um, hmm. But the thing is, okay, so that's very unique about this box. Why this set of 3 digits cannot add up to 8 as a set. I don't think it applies anywhere else where there's a 3 set. We don't have very many 3 sets anyways. The set of the 5 cell 8 lines can be broken up either multiple ways. You could have 8, 8, a set of 2, and then another 8. Um, you could have two digits and three. You could have two. I think it actually has to be. You could have two, one, two, and eight, and another pair of two. Hmm. So there's a lots of variety for the five length ones. Um. So these are going to have to be a four and a pair of two digits adding up to eight in this box. That's not too helpful. This can't be three. If this were, I was thinking this could be one, three, and four. But if this is three again, it has to be three and five with an eight on it. So obviously both of these could be there. Hmm. Okay. Um. Hmm. You could have three and five there. Well, one interesting thing is if this is a 1-7 pair, can we ever have one here? You would have to have. So if we had one here, obviously none of these can be one. This can't be a set of three digits adding up to one. So we are guaranteed. So that's interesting. So I don't think we can have seven here. If we have seven here, that would force one to be here. But then this set of three digits here could not be a set of three digits adding up to eight. You would have to have an eight guaranteed plus two digits adding up to eight. But that would eliminate eight being there. So if you had seven there, that would be one, and that would break. On the other hand, you could have one here, and then this is seven, and this could be a set of three digits. So that does kind of work. Huh. What happens if that's the case? So we have 1, 7. I don't think that actually works. 5 again has to be one of these digits here. But 5 here doesn't have a 9 below it, doesn't have a 1 above it. 5 is never going to have a 9 below it in these cells, and it can't have a 1 above it because 1 is guaranteed there. So this can't be 1 either. Interesting. Uh, and this is an aspect of Dutch flatmates which I'm not used to. I didn't think about this. Where is the 5 in row 1? It always has to have a 9 below it. Okay, so this is something that, because I'm not good at Dutch flatmates, so I don't spot these. 5 in row 1 guaranteed has to have a 9 below it. And the only place where 9 is below it in column 1, or row 1, is here. It's in column 9. So this must be 5 here, which means, again, this cannot be a 3-5 pair. You can't have 5, 1, and 2 here because that would eliminate all possibilities for this pairing here. So this must be 5 and 3, which makes this an 8 there. Interesting. That eliminates 3 in the rest of the box, so the rest of the box is 1, 2, 4, 6, 7. That eliminates 3 here, and this can no longer have a singleton here. So this has to be 1, 2, and 5 here. Because it has to have 3 digits adding up. So this can't be 1 or 2, it's 6 or 7. That can't be 6 or 7. The 5 has to have the 1 above it, so this can't be 5. And if this is 5, this can't be 1 here. If this is 5, obviously that can't be 1. If this is 5, 1 has to be above it, so this couldn't be 1. So 5 is one of the, this is 1, 2, 5 as a triplet, which leaves us 4, 6, 7 remaining. 6 and 7 would necessarily force this to be 1 or 2, but this can't be 1 or 2 because of the 1, 2, 5 triplet in the box. So this can't be 6 or 7. Therefore, this is 4, which means this can't be 4 there. 6 or 7, again, cannot be adding up to 8 with 3 digits, so this is 1 or 2, which forces this to be an 8 here. So this is 4 and 4. That eliminates 4 here. That also eliminates 4 here. This could be 3 with 1, 4, and 1, 4. Or it's 6 and 7, and that's 1, 2. So this is not really that much information. Well, this can't be 8 because of 8 in the column. So not 8, not 8 there. But this could be 3 digits adding up to 8 here. You could still have... you could have even 1, 6, and 1. That is possible. So this is 4, that's 4. We have 8 here. This is 3, so this cannot be 3 here. We can't have 3 digits here adding up to 8 because the possibilities are 1, 2, 5, and 1, 3, 4. 1, 2, 5 would eliminate all possibilities for that cell, and 1, 3, 4 is not allowed because of 3 here. So one of these has to be 8 and 2 digits adding up to 8. So this is 8, and this can't be 4, 5. It's 1, 2, 6, or 7. That means one of the remaining digits here are a pair of 1, 2, 6, and 7, and then a 4. But the problem there is if this is... I guess you could have 4, 1, 3. That is possible. You could obviously still have 4 and 4. Oh, this is 1 or 2. So we don't have 1 or 2 available. We have 4 and 5 here. So these two cannot be part of the same set because it's at minimum 4 and 5, which adds up this. So it's at minimum 4 and 5, which add up to at least 9. So this must be with a set here, and this must be with a set either here or these 3. So this could be 4 with 4 here, and 1, 2, 3. Five could be there still. Let's have a 1 above it. 5 is one of those two. Where is the 5 in column 7? It cannot. It's either one of these two, and it cannot be here. If this were 5, it can't have a 1 above it because of the 1, 2, 5 triplet in the box, and it can't have a 9 below it because of the 9 in the box. So the 5 has to be here, which makes this 1. Also, we have a 1, 2 pair in column 7, which eliminates 1 and 2 in the rest of the column. So this is 1, which makes this 7. That makes this 6 and 2. That eliminates 2 and 6 here. No 6 here. As a pair, this is a 4-7 pair, which eliminates 4 and 7 in the rest of the box and column. This can't be 7, it's 1. This can't be 7. Okay, I guess we can remove the reds. Remaining digits of column 7, we have 3, 6, 8, and 9. No 9 here. It cannot be 7 here. If this is 7, that doesn't add up to 8 with 3 or 6. So this is 4. Obviously cannot be 4 and 6 adding up, so that's 3. That means no more 3 in the rest of the column. 4 eliminates 4 here, so it's 7. This is 4, 3, and 1 to add up to 8. So these two must add up to 8 here. So no 4, no 1, 7 as a pair. It's 2, 3, 5, 6. 1 eliminates 1 here. So it's 2, which makes this 5, which makes have a 1 above it. So 1's above it there. So 5 is satisfied here. 5 is satisfied here. 5 is satisfied here. This can't be 5 anymore. And then 4, this can't be 3. If we had a 5 here, we could have a 9 below it still. So that's still fine. Remaining digits in box 6. It's 6 and 8 or 7. And we have a guaranteed 7 there. We have 2, 3, 6, 8 as possibilities here. No 8 here because of 8 in the row. This cannot be 2 and 6 to add up to 8. 1 eliminates 1 here, so this is 7, which makes that 1. So no 1 is allowed here. 5 can't be here. 5 has to be one of these 3. Cannot be here because of 5. It doesn't have a 1 above it or a 9 below it, so 5 has to be one of those 2. One has to be one of these 3. So this can no longer be 7. 7 would require a 1. Well, this is 4, 5, and 6. So this is a 4, 5, 6 triplet. Again, this is portion adding up with 8 there. This is adding up to 8 with either 2 of these. And it cannot be 2 of these because if it's 2 of these, you would have to have a 1 involved. So it could be 4, 3, 1 or 5, 2, 1, 2. But either one does not work because we already have 1s in the rows. So this must be 2 digits here, which forces this to be an 8 here. So again, this cannot be 4. So we have 2 and 3 adding up with 5 and 6 to add up to 8. 8 eliminates 8 there. Remaining digits of row 4 are 4, 5, 6, 7, 9. Obviously no 9 here because of 9 in the column being here. What else do we have? Remaining digits of row 1 are 1, 2, 3, 4, 6, and 9. Obviously no 1 there. 1 has to be one of these. Okay. 5 cannot be here because it does not have a 1 above it or a 9 below it. 5 could be here. You could have a 9 below it. 5 cannot have a 1 above it here, cannot have a 9 below it there, so that's not possible to be 5. 5 could have a 1 above it here, could have a 1 above it here, could have a 1 above it or a 9 below it there. Oh, this is a 4, 5, 6 triplet also, which eliminates 4, 5, 6 in the rest of the box. So this is a 1, 2, 3, 9 quadruplet in box 1, which eliminates 1, 2, 3, 9 in the rest of the box. So 9's guaranteed to be one of these 2. Which means this can't be 9 here. And we have to have 7 and 8 remaining in the box. That means this is going to be either 2, 3, 5, or 9 here. Again, this can't be 5 because of it doesn't have a 1 above it or a 9 below it. Ah. So, 2 or 3. This 2 or 3 adds up to 8 with this. If this were 5 or 6, it would guarantee to have the 2 or 3 be here. Therefore, this can never add up to 8. The corresponding, I should say, 2 or 3 that adds up to 8 with it in one of these 3 cells. So this can, if this were 5 or 6, the 2 or 3 that it adds up to 8 with could never be here. So this cannot be 5 or 6, so this must be 4, which makes that 4 there. This 2 or 3 has to be there, and we also have 6 there. This can't be 4. I don't know. I feel like this is definitely not easy. I don't understand why people are rating this easy. Again, that's why you take these things with a grain of salt. Because sometimes people... this is not easy. 4 eliminates 4 here. Even though I'm not good... I have very bad intuitions with Dutch flatmates. This is still not easy. We cannot... we could have a 9 there if this is 5. No 5 here, no 5 here. So we have 5 possible being there. No, 5... Okay, so 5 can't be here or here because 5's in the row. 5 can't be here because it doesn't have 1 above it or 9 below it. So no 5, no 5, no 5. No 5, no 5. So where's the 5 in column 6? It has to be here. That's the only place. And it does have a 1 above it, so this can't be 5 here, no 3 here, no 5 here. This 2, 6 pair eliminates 2 and 6 in the rest of the box. So no 6 there. Well, where is 5 in row 4? It has to be here. So this is 5. It does not have a 1 above it, so it must have a 9 below it. That means this can't be 9. So where is 9 in box 1? It has to be here. That means this can't be 5 because it doesn't have a 1 above it or a 9 below it. So this is 6 and 2, which makes this 5 with a 1 above it being there. 2 eliminates 2 here, so this can't be 1 or 2. It's 3. That eliminates 3 in the rest of the row. 2 eliminates 2 in the rest of the row, so this is 3, 5, and 9. Okay. This 5 has a 1 above it, so that's fine. No 2 and 6 here. No 4 here because of 4 in the row. This can't be 8. This can't be 8. So 8 cannot be any of these. Interesting. So this has to be 1, 2, 3, 4, 5, 6, 7. No 1 or 7 here because of 1 or 7 in the row. No 2 or 6 here because of 2 or 6 in the column. No 3, 4, 5 here because of 3, 4, 5 in the column. This can't be 4 here. This can't be 5. So these... what about this? This could be an 8. We could have 1, 2, 6, or 7 there. Can this ever be 4? Yes, 1, 3, and 4 does work there. 5 cannot be here, so 5 is one of these two. Aha. 5 can't be here because it... Or 5 could be here if 1 is above it. But it cannot have 9 below it. 5 could be here if 1 is above it, so 1 has to be one of those two. Interesting. Remaining digits of column 2, we have 3, 4, 5, and 7, and 1 can specifically be in these two spots. If this were 5, so one of these two is a 5. If we have I guess you could have 5 and 3 there, and then this is 1. And then this would be 8. So if this is 5, 3 would have to be here. Because we need a 1 above it, and this doesn't add up to 8 with any of these possibilities here. And we can't have 3 digits doing that if this were 5, because 3 and 5 already add up to 8. So we have to 5, 3, and this would be 8 there. That would force this to be a 2, 6 pair here, adding up to 8. Or we have this be 5. It has to have the 1 above it. You could have 7 there. So 7 and 1, and then 5, 2, and 1 does add up to 8. Or it's 5, 1, and 2, and then this would be 6 with 2 adding up to 8. So either of those work. Interesting. Remaining digits of box 5. We have 3, 4, 7, 8, 9. No 4 here, obviously, because of 4 is in the rows. No 8 here because of 8 in the row, or in the column. No 7 here because of 7 in the column. We have a 3, 9 pair then in column 6. So the remaining digits are 2, 4, and 6. This can't be 4 because of 4 in the row. So where is the 4 in column 7? It has to be here. 4 eliminate 4 and 8 eliminate 4 and 8 there. This becomes a 3, 7, 9 triplet, which eliminates 3, 7, 9 in the rest of the box. So this can't be 7 or 9, it's 4. No 4 here. That means it can't be 3, 7, or 9 here. It's 8. It is 8, which means it can't be 8 here. This 6, 7 pair eliminates 6, 7 in the rest of the box, so no 7 here. It's 9, which eliminates 9 here, so it's 3, which makes that 7. 3 eliminates 3 here, so it's 9, so no more 9s there. This is a 3, 5 pair, but either of them could be 3 or 5, because this 5 has a 9 below it, and this 5 has a 1 above it. 3 and 5 eliminate 3 and 5 here, no 5 here, or 7. 7 eliminates 7 here. Where's the 7 in box 6? It has to be there. So that's 7, which makes that 6. Okay. 9 eliminates 9 here. Where's the 9 in box 6? It has to be there. 6, 8 as a pair eliminates 6, 8 in the rest of the row, so no 6 here. It's 2, which makes that 6. 2 eliminates 2 here, so it's 6, which makes that 2. 2 eliminates 2 here, so it's 6, which makes that 8. 8 eliminates 8 here, so it's 6, which makes that 8. That eliminates 8 in the rest of the column. 8 cannot be here. Interesting. So this, again, could be 1 and 7. Okay, so this cannot be 5 here. Because if this were 5, you would have you cannot add up to 8 with these two, and you cannot add up to 8 with these two, or you cannot add up to 8 with these 3. So this cannot be 5 here, which means 5 has to be here, which means 1 has to be above it for that to be satisfied for the Dutch flatmates. 5 here does not have a 1 above it, so it must have a 9 below it, so 5 has to be here to have a 9 below it there. That eliminates 5 there, so it's 3 and 5. That's satisfied to have the 9 below it. So again, 5 has a 1 above it, 5 has a 9 below it, 5 has a 1 above it, 5 has a 9 below it, 5 has a 9 below it, 5 has a 1 above, 9 below, 1 above. So again, no 5 here, no 1 here. 4 eliminates 4 as a possibility here. No more 6 here. So this could be 1, 7, and then 5, 2, 1. Or 1, 2, 5, and then 6 and 2. We don't know which. 9 eliminates 9 here, so the 9 in box 7 has to be here. Remaining digits of row 5 are 3 and 4. That 3, 4 pair eliminates 3 and 4 in the rest of the box, so no 4 there. It's 7. That leaves this as a 1, 2 pair here. 1 can't be here because of 1 in the column, so that's 2, which makes the 1 there. 6 eliminates 6 here. Remaining digits of column 4 are 1, 2, and 3. No 1 here because of 1 in the row. So we have a 2, 3 pair in row 7, which eliminates 2 and 3 in the rest of the row. So no 2 here. It's 7. So it's a 7 and 1 adding up to 8. We cannot have 5 and 6 here. That adds up to 11. So it's 5, 2, and 1 here to add up to 8. 2 eliminates 2 here. So it's 3, which makes this 2. 2 eliminates 2 here, so that's 3. This can't be 2 or 3 because of 2 or 3 in the row. So that's 6, which makes that 2 there. Remaining digit of 7 eliminates 7 here, so it's 8 and 7. Remaining digit of row 8 is a 4. That eliminates 4 here, so it's 3 and 4, which makes that not 7 here because of 7 in the column. So that's 3. Remaining digit of column 1 is an 8. This is a 6, and this must be a 7. Thank you for playing. Did you notice there are 8 lines? I did not. 1, 2, 3, 4, 5, 6, 7, and 8. But yeah, I still would not consider this easy. The execution, the logic isn't that bad. The execution, though, is pretty challenging. So, granted, again, I am not good with Dutch flatmates, so I didn't spot this almost immediately, which probably if you're good at Dutch flatmates, you would have spotted immediately. But even then, there was some tricky stuff here going on. So, I don't know. I would consider this challenging. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.